Are you a builder? Could you stand the concept that you might be able to learn something from another builder? How'd you like to learn how to save $38,000 just in the cedar cladding on one house? That's a significant saving. Every builder wants to make more money, but not every builder thinks the process through. If you'd like to learn more, then I encourage you to have the patience to watch this video all the way through and to learn from it what is significant and how you can make more profit in your business. I'm Lester, the cost engineer. Now, most builders are looking for ways to make more money and be more efficient on building sites. Prior to Christmas, Eddie Cooney showed us one of his building sites, and he talked to us about the methodology he uses to be more efficient in the handling of cedar and the installation of cedar cladding. And this raised some issues, particularly around how do we calculate the hours required and what sort of savings and efficiency can Eddie achieve. So what I want to do in this video is show you how you can make a lot more money by looking at things the way Eddie Cooney does. In other words, more efficiently, questioning your current procedures and processes and finding better ways to do things. So let's get stuck in and see if we can save you tens of thousands of dollars in how you install your cedar. So the first thing I need to do is lay a foundation of understanding so that we're comparing apples with apples and you know the figures involved. The first thing you see here is a part of the takeoff that Eddie did. He used Bluebeam Software, and you can see that he's come up with a net cedar area of 315.7 metres squared. If you want help in understanding Bluebeam, then follow the links below and we can train you on how to use this software to do your takeoffs. So what we've established is there's 316 metres squared of cedar cladding, and what you need to consider is the coverage. In this case, he's using 135 wide by 18 thick boards, and that gives us an effective coverage of 110 millimetres. So if you divide that into a metre squared, or 1,000, you'll find that it's 9.09. In other words, there's 9.09 linear metres of cedar per metre squared of coverage. So if we multiply that out, we find that the 316 metres squared equates to 2,873 linear metres of weatherboard. We also want to account for wastage. So we're going to use 15%, and the main reason we're using 15% is because Eddie is considering the amount of arrow grain that might appear, and he doesn't want that arrow grain to show in the cladding. We know we need 2,873 linear metres of cedar. If we multiply it by the 15% wastage factor, we end up with an order quantity of 3,303 linear metres. Let's just round that to 3,300 linear metres of cedar to order. Now we need to consider how much of that are we going to fit. The net quantity we're going to fit is 2,873, but we're going to handle 3,300. So I'm just going to take a rounded figure of 3,000 linear metres to fix as a labour calculator. So the two key figures I want you to remember is that we've got 330 metres squared to cover, and that equates to roughly 3,000 linear metres of cedar weatherboard. Now the first example I'm going to work to is this custom run horizontal, rusticated and rebaited cedar weatherboard. This is a photo from one of Eddie's jobs where he did this work. And we're going to use Eddie's figures to compare his efficiency, his speed of installation to other builders, and what would the savings be if we use Eddie's methods. So let's get started by using Labour8 to calculate the labour difference between Eddie and other builders. For those of you who haven't seen Labour8 or don't understand the principles, I'm just going to show you a quick introduction. You can see here in this job under this item, custom run horizontal rusticated rebaited cedar weatherboard with custom fixings, and we've got a total quantity of 330 metres squared, so that's our item. And if I want to find a labour constant for that, I've got one of two methods. I click on here and it gives me all the drop downs. So I've got carpentry cladding, carpentry concrete, carpentry doors, windows, stairs. Now there's over 2,500 labour constants in here, and it's too hard to click on these and drill down. It takes too long. So what you do is just type in what you're looking for. In this case, custom run. I do a search, it filters down, and then I follow that search. See that? And what I'm going to find here is the labour constants applying to this. Now the first thing to recognise is these two here are metre squared constants. They're not linear metre, and our item over here is metre squared, so that suits perfectly. Then I put in my 330 here, So that's my quantity. And you'll see now if I tick this particular labour constant, if you look over the right at the hours, it's calculating 986 hours of labour content to fit that weatherboard. Now here's the difference. A normal build is 986, but Eddie is 702. And that's a difference of roughly 280 hours, quite a bit. So if I overlay that now with the carpenters I'd get to do that labour there, and the cost is dependent on the true cost of the labour. Not their contract rate, but their true cost, all the additional parts that go into it. So in this case for Alan it's $44 an hour, for Brian it's 40, and we'll use Donald here, the hammerhand, to be the third person on this. And you can see here that I've got a cost of $39,425. But if I use Eddie's team, that jumps down to $28,000. It's a marked difference. Let's now do the mathematics to make our comparison. Remember, we're doing this custom run, horizontal rusticated and rebaited cedar weatherboard. So we know we've got 330 metres squared, and that if we use a normal crew, it's 986.7 hours of labour to fit that cedar. In Eddie's case, it was 702.9 hours. So the 986 minus 702 gives us a difference of 283 man hours. So what are those man hours worth? Well, at $70 an hour, that comes into close to $20,000 excluding GST, or including GST, $22,846. Quite a marked difference. Can you now see the benefits of listening to what Eddie has to say about site efficiency and the handling of materials? Let's go to example number 2. In example number 2, we're looking at board and batten cedar. So how does that compare between Eddie's method and your average builder? Well, here's our board and batten cedar. Put in our figure of 330. We do our search for our board and batten cedar. Drill down, find the labour constants. So your average builder would take 1,471 hours, but Eddie's crew would take 917 hours. Applying those same builders we did in the first example, we see a cost difference here of $27,000. Remember, this is cost, not retail value. Or if we use an ordinary builder, $43,900, a marked difference. If we go back now and table our costs, this is the comparison we see. We have 330 metres squared. If we take your average builder at 1,471 hours, and we compare them to the 917 that Eddie's crew would take, that's a difference, quite a large one in this case, of 554 hours. In dollar terms, that 554 hours equates to nearly $39,000, or $44,000 if you include GST. Again, a very marked difference that you could profit from. We'll move on now and do example number 3. In example number 3, we're looking at vertical shiplap cedar with 155 millimetres of coverage. Now there's a slight difference in our calculation here. Because it's 155 millimetres of coverage, we don't need as many lineal metres of cedar. In fact, we can reduce this from 3,000 linear metres to 2,128 linear metres. So let's go into Labour 9 and do the comparison. So we can see here that an ordinary builder would take 1,000 hours to install that vertical shiplap, but Eddie's method is a lot more efficient and he can do it in 829 hours. Let's now make our comparison. Because it's 155 millimetre coverage, we're installing 2,128 linear metres of cedar. And an ordinary builder would do it in 1,000 hours, and Eddie's crew can do it in 829 hours, so there's 170 hours of difference. So if we multiply that by the $70 an hour, Eddie's crew is nearly $12,000 cheaper, or $13,000 including GST. Let's now move on to our last example. So here we have horizontal bevel back cedar. The weatherboard coverage here is 110 millimetres, and we know that we're going to have to install 3,000 linear metres. So in Labour 9, we look up the labour constant. Here we have a labour constant with 3,000 linear metres. You can see over here it's 960 hours, and it's going to cost $38,000, but Eddie's crew would take 570 hours at $22,000. So once again, comparing our figures. So you can see we've got a difference of 390 hours. And Eddie's crew could do it for roughly a $27,000 difference, or including GST, $31,000. Quite substantial. we can summarize from all of this information that it may pay to scrutinize what you do and how you do it. That it may pay for you to consider using better tools for calculating these things, like Labour8, and engaging with the likes of Eddie Kearney and myself to understand better methods so that you can reduce your production times and therefore the profitability and also your saleability to your clients. So if you'd like to do that, I'd encourage you to do two things. Our contact details are down below. I'd also encourage you to do the like and the subscribe to this YouTube channel, because we've got another video coming shortly where I interview Eddie about these figures and we go into a bit more detail. So please subscribe and like, and let's see if we can help you to have a more profitable and efficient operation. Thank you. I'm Lester. If you want to know more, here are all the buttons and resources that you need. Just use these links to go places. Don't forget to share this video with friends who you think might need this video.